Hi guys, this is Dr. J here, and in this video we are going to briefly talk about nucleophilic addition reactions of aldehydes and ketones. So in this video we will talk about the general mechanism for the nucleophilic addition reactions of aldehydes and ketones, actually one of the two mechanisms, and then we will also talk about a couple of reactions that are going to fall under nucleophilic addition reactions. So first of all, let's talk about why there is nucleophilic addition reactions of aldehydes and ketones. So both aldehydes and ketones, as you know, shares a carbonyl group. Okay, they both show this carbonyl group, which is basically sp2 hybridized, right? So both carbon, oxygen and the R groups, they are on the same plane. Okay, so this sp2 hybridized carbonyl group, or the carbon of the carbonyl group, is actually polarized. Why? Because of course that carbon is attached to the second best electron thief in the periodic table. So because of the electronegativity difference between oxygen and carbon, the carbon is going to be partially uh, positively charged, or you can say it is electrophilic, and of course oxygen is partially negatively charged. Because of this polarization, okay, carbon, as I mentioned earlier, is electrophilic, which means the nucleophiles tend to attack this carbon right here. Okay, so this many nucleophiles tend to attack this electrophilic carbon on the carbonyl group. Okay, so usually this attack uh, is actually happens in a somewhat of an angle. Okay, so the nucleophile approaches around approximately 75-degree angle to the plane of carbonyl. Okay, and also once the nucleophile attacks on the electrophilic carbon, okay, of course it is going to have 5 bonds, so you have to break a bond, right? You have to break a bond. So basically one of the carbon oxygen double bonds will break onto oxygen, and then it will make a tetrahedral alkoxide ion intermediate. Okay, so you will have an intermediate like this, which is an alkoxide ion, and of course it will be tetrahedral. So now in this intermediate, the hybridization of the carbon will be switched from sp2 to sp3. Okay, it will switch from sp2 to sp3. All right, and then once this intermediate is formed, it will be protonated. This alkoxide ion will be protonated. Okay, will be protonated and form an alcohol. It will form an alcohol. All right, so this is how it happens. All right, so you are basically adding a nucleophile into the carbonyl carbon. Okay, into the carbonyl carbon, and also you will make an alcohol. Okay, you will make an alcohol that contains a nucleophile. Okay, that contains another new group. So basically there is another a nucleophilic addition reaction which takes place uh, on the carbonyl oxygen atom, but after protonation of the carbonyl uh, oxygen atom, okay, it will eliminate an OH minus or a hydroxide group or a water molecule, giving products that contains a carbon double bonded to a nucleophile. So we will talk about that mechanism in a separate video, but for now this is the nucleophilic addition reaction that we are going to focus on in this particular video. Okay, so in here once again it will go through a tetrahedral alkoxide ion intermediate, and then followed by protonation to give you an OH group. All right, so the first reaction that we are going to talk about in this video is the addition of HCN. Okay, HCN, or you can say cyanohydrine formation. This is the next reaction we are going to talk about in this video. So in this reaction you are basically going to form cyanohydrines. Okay, so the thing about cyanohydrines is that uh, cyanohydrin is a compound where a carbon is attached to a CN or a cyanide group as well as an OH group. Okay, so those type of compounds with a carbon that is attached to the same OH group, I mean a carbon attached to both an OH group and a CN or a cyanide group, is known as a cyanohydrin compound. Okay, so for this reaction, of course, you are going to need an aldehyde or a ketone. Aldehydes are more preferred, I would say, because they are less crowded. So usually reactions are faster when it comes to aldehydes, because the aldehyde carbonyl carbon is less crowded. Okay, but of course, when you have an aldehyde or a less crowded ketone, okay, the addition of HCN happens through the treatment of cyanide ions. So basically, this addition of HCN is reversible and base catalyzed. Okay, and base catalyzed. So let's take a simple carbonyl compound. Let's say you have something like this. Excuse me. So here is your carbonyl compound, and then the nucleophile will be, of course, a cyanide ion. Cyanide ion will be your nucleophile, and it will attack the electrophilic carbon of the carbonyl group, breaking one of the double bonds onto oxygen, forming a tetrahedral alkoxide ion, Okay, so now the hybridization of carbon has changed from sp2 to sp3. And then once you have this, of course, it will go through protonation. Okay, most of the times the proton will be given from an HCN molecule. Okay, HCN molecule will give the proton to the alkoxide ion, forming the respective alcohol. Okay, forming the alcohol. All right. So by the way, this reaction is reversible, and of course, let's say if the carbonyl group is crowded, this reaction will not be favorable. Okay, will not be favorable. And this is how you add a cyanide group into a carbonyl. Okay, into a carbonyl. And then this reaction has some very important advantages, especially there are multiple uses for cyanohydrins. Okay, cyanohydrins, which is the compound that we formed in the previous reaction. Okay, so this cyanohydrin actually can undergo a couple of very useful reactions. The first reaction that we are going to talk about is reduction. So this reduction happens through lithium aluminium hydride. So the most common reducing agent is going to be lithium aluminium hydride. Okay, so let's take a general cyanohydrin. So let's say you have a benzene ring attached to a carbonyl, attached to a, sorry, not the carbonyl, now it will be an OH group after cyanide formation. And then here is your cyanide, and then let's say this is a hydrogen. Okay, this will be our cyanohydrin, and then you are treating this with lithium aluminium hydride. You are treating it with lithium aluminium hydride. But of course, to complete the reaction, you will put some water. Okay, so this is a reduction. Okay, this is a reduction, and what happens is that this cyanide group right here, let me write it down in a different color so that it will be clear to you. The cyanide group will be reduced. So basically, the product that you get is something like this. Pay attention to what happens. Okay, so benzene group will remain unchanged. Nothing will happen to that. Of course, the carbon and the OH and the hydrogen, they are all the same, but the carbon will be converted to a CH2, and the nitrogen will be converted to an NH2. So basically, if you want to learn this reaction graphically, this is what has happened. Okay, so of course, you know the cyanide is a carbon nitrogen triple bond. It has a carbon nitrogen triple bond, right? So basically what we are going to do is we are going to break the triple bond. Okay, So we are taking off 2 bonds from both carbon and nitrogen. So nitrogen gets 2 hydrogens as in order to compensate the 2 bonds, and carbon gets 2 hydrogens, right? So this is how it happens. Both carbons and nitrogens will get 2 hydrogens each. Both carbons and nitrogens will get 2 hydrogens each. Okay, we'll get 2 hydrogens each. So this is a very important reaction. Why? Because this reaction will give you a primary amine, which is this one right here. Okay, this right here is a primary amine. Okay, so this is a primary amine, and also that compound will also have an OH group. Maybe you will later on change the group into an alkyl halide and maybe do some other reactions. So this basically gives you a lot of opportunities, right? So if you want to generate a primary amine out of almost nothing, this is a really good reaction. So keep that in mind. Okay, this has some very good advantages. The next reaction that we are going to talk about is hydrolysis. So basically, let's use the same cyanohydrin. Okay, so you have a benzene, which is this one, then the carbonyl. Oh, we are using the cyanohydrin, so it will be OH and the C N. Okay, and there will be a hydrogen. So this is the cyanohydrin, and we will treat it with a hot acid. Okay, hot acid. So we are basically hydrolyzing it using a hot acid. Okay, always put some heat. It should be hot. All right. So what happens is that in here you will not do anything to the benzene ring. It will remain as is, and the OH group will be the same. Okay, there will be a hydrogen. I'm not going to show that on this carbon. Okay, you know that. But the cyanide group will change. So I'm going to use a different color and then show you what is going to happen. Okay, so here is the CN. This is the cyanide group that we had. Okay, so the carbon will be converted to a carbonyl group. So carbon will be a carbonyl, and then the nitrogen will be an NH2. Okay, this is what happened. So let's go back. This is also a very, very important compound. Okay, so this hydrolysis will give you an amide. This hydrolysis will give you an amide. Look at it. You have an amide. Okay, so that is a very important group of compounds. So it will basically get you an amide very easily through the cyanohydrin. Okay, and let's see what happened. If you want to learn this reaction through a graphical technique. Okay, if you want to learn this reaction through a graphical technique, so basically the cyanide had a triple bond. Okay, it's a triple bond. So this is hydrolysis, right? So this is hydrolysis. So you are basically adding water. Okay, so water is what? H2O. So you are breaking oxygen and the 2 hydrogens separately. Okay, so what you do is you will break the triple bond. Okay, now both carbon and nitrogen lost 2 bonds, right? And then this carbon will get the oxygen. This nitrogen will basically get the 2 hydrogens. Okay, so nitrogen gets the 2 hydrogens, carbon gets the oxygen. So you get the amide. All right, remember these 2 reactions. They are very important. Okay, they are very important. All right, so the second reaction that we are going to talk about, is the addition of Grignard. Okay, addition of Grignard reagent. I'm pretty sure you are already familiar with this reaction from before. Okay, you're already familiar with this reaction. So if you don't remember what is Grignard, it has a carbon ion containing magnesium salt. Okay, so this is how it looks like, X being a halogen. Okay, so let's use a bromide maybe. Okay, so this is a Grignard reagent. The unique thing about Grignard is that it is going to have a carbon ion. It is going to have a carbon ion, which is an excellent nucleophile. this right here, this R minus is your nucleophile. Okay, this right here is your nucleophile. So it is an excellent nucleophile, and it will easily add to carbonyl groups. Okay, it will easily add to the carbonyl of aldehydes and ketones. Okay, it will easily add to the carbonyl carbon of aldehydes and ketones. So let's take an example reaction. So let's take an aldehyde. Okay, let's take something like this. All right, that is a simple enough aldehyde. Okay, and you're adding the greenard. So greenard is, let's say, C2H5 MgBr. All right, so basically the R group or the carbon ion will attack the carbonyl carbon, and this will break onto oxygen, forming an alkoxide ion. So the cyclohexane ring is unchanged, nothing happened to that. The carbonyl carbon is now an sp3 hybridized carbon, of course. And then let me use blue color so that you can track what's going on. Okay, for some reason okay, so I'm sorry about that. Okay, all right, so here is the R group, a 2-carbon R group. Okay, and then what you do is you will treat it with a mild acid or water. Okay, you will treat this with a mild acid or water, and then what you get is an alcohol. So once again, guys, this reaction is extremely important. Why? Because it adds carbons. Okay, so this reaction basically will add carbons. So therefore, any reaction that can easily add carbons is an important reaction. Okay, so you can easily make very complex compounds starting with very small organic compounds. So therefore, any reaction which is capable of adding carbons are especially important in organic chemistry. Okay, and this is how it happens. And I think we learned this reaction multiple times before. So if you want more details, I recommend that you basically go and review those videos as well. Okay, but I mean, that is a very straightforward reaction that will add more carbons to it. Okay, and the third and final reaction that we are going to talk about is reduction, or in other words, addition of hydride. Okay, addition of hydride. So this happens, the addition of hydride happens through usually lithium aluminium hydride or sodium borohydride. So the most common reagents are going to be either lithium aluminium hydride or sodium borohydride. These are the more common reagents. Okay, and then of course it will be followed by some acid. Okay, so there will be a protonation to generate the alcohol. So these are the two reagents that you need for the reduction. Okay, lithium aluminium hydride or sodium borohydride followed by H3O plus. So in here what happens is that you will add a hydride. So both lithium aluminium hydride or sodium borohydride will give up a hydride as the nucleophile. So that nucleophile will go and attack the carbonyl carbon, which is an electrophilic carbon. Excuse me. I'm sorry about that. Okay, which is an electrophilic carbon, and then it will break onto oxygen, giving you an alkoxide ion. Okay, So everything is unchanged other than the carbonyl carbon hybridization, and it will also add a hydrogen. Okay, so this is the alkoxide, but of course you will treat it with what? An acid, mild acid, which will protonate the alkoxide ion. generating NOH. So very straightforward, right? Very straightforward. So this is the reaction. So with that, I'm going to conclude this video. So let me summarize what we discussed. We talked about the general mechanism of electrophilic addition reaction, where the nucleophile will attack the electrophilic carbonyl carbon and forming an intermediate that is tetrahedral, and also it is an alkoxide ion, and then you will follow that with a protonation to generate an OH group from the alkoxide ion. Okay, the first reaction that we talked about is addition of a cyanide. Okay, a cyanide. Usually in this reaction you generate cyanohydrines. Okay, cyanohydrines where a cyanide and a OH is attached to the same carbon. Okay, so this is a very sensitive reversible reaction, by the way. So if you use a crowded ketone, this reaction will not happen. Okay, so keep that in mind. So this is only for simple, less crowded ketones and aldehydes. And then cyanohydrines are actually very important because they show a couple of very interesting reactions. First reaction that we talked about is the reduction of cyanohydrines, where you basically add two carbons, two hydrogens to both the carbon and nitrogen of the cyanide group, okay, CN group. And then the hydrolysis basically will add an oxygen to the carbon and then two hydrogens to the nitrogen, giving you an amide. So basically, cyanohydrines can directly give you a primary amine or an amide. Okay, so that is why cyanohydrine is very important. And then we also briefly mentioned about the addition of Grignard. Okay, but we have learned this Grignard reaction multiple times, so I was just summarizing what we learned. This Grignard is especially important. Why? Because it will add carbons to the carbonyl carbon. Okay, so you can generate very complex organic compounds starting with very small very simple organic compounds. Okay, so this is an important reaction. And last but not least, we'll talk about the reduction of carbonyl compounds, aldehydes and ketones. Okay, you can use lithium aluminum hydride or sodium borohydride, okay, for the reduction. In here, these reagents will basically give out hydride ions, okay, and it will basically convert the carbonyl group into an alcohol. So if you use an aldehyde, okay, you get primary alcohol. So if you use an aldehyde, let's write it down so that it will be a nice summary. If you use an aldehyde, you get a primary alcohol. But if you use a ketone, it will get you what? It will get you a secondary alcohol. So that is a nice summary to this video. Just let me know if you have any questions, guys. Okay, you guys have a nice one. Take care.